Hello, hello. We're going to convert now between not just moles to moles, but sometimes grams all the way to grams of the other thing, or atoms of something to the atoms of the other thing. So it's going to be taking a longer time to do that. It's going to take a few more steps, but it's not any more difficult. It's just you have to include that within your train tracks. All right, so what we're going to do first is balance the equation. We have Fe plus O2 goes to Fe2O3. I'm going to balance my oxygens first. There's 2 on the left side, there's 3 on the right side. Let's get those both to 6. So now I have 6 on the left side, and I have 6 on the right side. Remember, we do have to put those coefficients out front. I cannot put a coefficient in here. That would not be allowed. Next, we have to balance our irons. We have 4 on the right side, we have 1 on the left. So we need to make sure that there's 4 on that left side as well. Okay, that is balanced. Now, I know that I'm going to be doing some things going between grams and moles here. And for this, we do have to use the molar mass. So what I'm going to do just to save my time later is just I'm going to calculate all the molar masses here. I'll calculate the molar mass of iron, oxygen, and iron oxide. Okay, so on your periodic tables, you should be able to find iron's molar mass. I'm going to find it real fast. It's 55. Iron's molar mass is 55.845. Oxygen, it's normally 15.999 if there's 1, but we have 2, so we have to make sure that we include that. So oxygens is going to be 31.998. Remember, these are in grams per mole. Grams per mole. Sometimes I even forget to put my units, but I shouldn't. And then lastly, we have iron 2O3. So let's go to 15.999 first. That's my oxygen. There's 3 of those. Plus my iron by itself is 55.845. And there are 2 of those. Adding all those up, that's going to get us 159.687 grams per mole. Okay, so that'll just save us some time later to put that all at the top right now. First question: how many grams of iron oxide are produced when 42.7 grams of iron is reacted? So we are trying to find this. We're trying to find this, the grams of that, if we start with the grams of this. Okay, so that means if we have grams of one thing, we first have to find the number of moles in that amount of grams for that substance. And then we can use our balanced chemical equation to use those coefficients out front and find the number of moles of that other thing that are around. And then we can finally convert using our molar mass from that moles of the second substance to the grams of that second substance. So in the end, it's going to actually be 3 steps. Let's start with what we're given. 42.7 grams, 0.7 grams of iron. We know in this first step, we have to use our molar mass here to get from the grams of this thing to the moles of this thing. So let's use the molar mass that we've already used for iron, or that we've already found. It's right here. That is iron's molar mass, 55. There's 55.845 grams of iron per mole of iron. All right, at this point, we now have moles of iron. Now we can use our balanced equation, which is right here, to go from number of moles of iron to number of moles of iron oxide. So let's use those coefficients. We know that there are 4 moles of iron for every 2 moles of iron oxide. How do I know that? Because there's a 4 in front of my iron and a 2 in front of my iron oxide. Those coefficients go down there. Now I have moles of my second substance, iron oxide. I am now here in my diagram. So I just need to make this last jump, use molar mass, and go from the moles of that thing to the grams of that thing. Okay, I already have my molar mass of iron oxide. It's right there. So for every, we have moles up here. We have to make sure moles go on the bottom now. For every 1 mole of iron oxide, we have 159.687 grams, and I kind of ran out of room there, but it's grams of iron oxide. All right, we can bring out the calculator now. Let's go down the line. 42.7 divided by 55.845 times 2 divided by 4 times 159.687, and that is going to equal 61.05. I'm just going to round to 2 decimal places there. All right, and that's going to be, our last unit there was grams of iron oxide. Grams of iron oxide, Fe2O3. Okay, that's that problem. It's the same process of what we've been doing all this time. It's just that the conversions are larger because there's more steps to do. Next problem, how many atoms of iron are needed to react with 7.1 times 10 to the 23rd molecules of oxygen? So now I'm starting with oxygen, molecules of oxygen, and I'm going to atoms of iron. Let's find that. So I have molecules of something, which is essentially, we're going to treat it very similarly to atoms. So we have molecules of oxygen, we have to find the moles of oxygen, then we can find the moles of iron, and then we can find the atoms. I think we are finding atoms, correct? Yes, the atoms of iron. So it's again a 3-step process. Let's put our original number down, 7.1 times 10 to the 23rd molecules of oxygen. We know based on Avogadro's number that there are 6.02 times 10 to the 23rd molecules of oxygen for every 1 mole of oxygen. So that'll help us transition from molecules to moles. After that point, we then have to transition using our balanced chemical equation, going from moles of oxygen, and we're trying to get iron, so we need to get moles of iron. Okay, use your balanced chemical equation here. We started with oxygen, we're going to iron. That is a 4:3 ratio. So from that equation, we had a 4 in front of our iron and a 3 in front of our oxygen. We no longer have molecules of oxygen. Now our last step here, because we are trying to find the atoms, we have to convert from moles of iron to atoms of iron. So once again, we are going to have to use Avogadro's number. How many atoms are in a mole of anything? 6.02 times 10 to the 23rd atoms of iron. All right, we kind of ran out of room there, so I'm going to shrink this a little bit. Okay, let's bring out the calculator. Going down the line, we have 7.1 times 10 to the 23rd divided by 6.02 times 10 to the 23rd times 4 divided by 3 times 6.02 times 10 to the 23rd. And that is going to get us 9.47 times 10 to the 23rd atoms of iron. Okay. Last problem. How many molecules of oxygen would be formed if 93.1 grams of iron oxide is created? So we are going from iron oxide to oxygen. That means we're going from here to here. And we're going from grams of iron oxide and eventually going to end up with molecules of oxygen. So essentially we're going from, let's delete that, going from grams over here, changing to moles of the other thing, and then ending up with atoms of the other thing, which is actually the same conversion as molecules. But here we go, 93.1 grams of iron oxide. Check that, make sure that was right. Yep, of iron oxide. And that's going to, using the molar mass of 159.687 grams of iron oxide per 1 mole of iron oxide. That'll change our units to moles. Then we use our balanced chemical equation to go from moles of iron oxide to moles of oxygen. We have a 2 and a 3. That 2 is in front of iron oxide, so we'll put that down there. And that 3 was for our moles of oxygen. Using that, we've now converted from moles of iron oxide to moles of oxygen. And our last step is to convert from moles of oxygen to molecules of oxygen. Again, we just use that standard 6.02 times 10 to the 23rd. That is the same number you're going to use every single time to go from a mole of something to the number of particles or number of molecules or the number of atoms of something, Avogadro's number. Okay, let's calculate it. 93.1 divided by 159.687 times 3 divided by 2 times 6.02 e to the 23rd. The reason I can put all these into my calculator all in a row is just due to order of operations. Multiplication and division always happen simultaneously. We'll use 2 decimal places times 10 to the 23rd, and this is, our unit is molecules of oxygen. There you go. Those are 3 different problems, but they are all using the same balanced equation.